It began with a simple question. What happens if a planet has two suns? For decades, astronomers believed they already knew the answer. A world trapped between two stars would live in chaos. Gravity would constantly shift. Orbits would become unstable. Temperatures would swing wildly. Most scientists thought a stable, Earth-sized planet in that kind of system simply shouldn't exist. Then one telescope changed everything. In 2011, researchers studying distant starlight noticed something strange. A tiny dip appeared in the brightness of not one, but two stars orbiting each other. At first, it looked like a mistake. Instruments fail. Data gets corrupted. Strange signals often disappear after closer inspection. This one didn't. Every few months, the same pattern returned. Something enormous was passing in front of both stars. The discovery shocked astronomers because it wasn't just another exoplanet. It was a circumbinary planet, a world orbiting two suns at the same time, much like the fictional planet Tatooine from Star Wars. Only this wasn't science fiction anymore. It was real. The planet became known as Kepler 16b. At first glance, it seemed to prove that nature could do things scientists never imagined. But the deeper researchers looked, the stranger the mystery became. The two suns weren't peacefully sitting side by side. They were locked in a gravitational dance, racing around each other every 41 days. Their combined gravity constantly shifted through space like an invisible storm. According to many computer models, building a planet inside that environment should have been nearly impossible. Tiny rocks that normally stick together during planet formation would instead smash into one another at incredible speeds. Instead of creating planets, the system should have destroyed them. Yet somehow, one survived. Even stranger, it wasn't alone. As NASA's Kepler Space Telescope continued searching the galaxy, more planets with two suns began appearing. One discovery became 2, then 5, then 10. Today, scientists know of multiple circumbinary planets scattered across our galaxy. Each one challenges the same assumption. If these systems are so violent, why do these planets exist at all? Researchers began running massive computer simulations to recreate the birth of these strange worlds. Again and again, the results ended in failure. The growing planets either spiraled into one of the stars or were completely thrown out of the system. It was like trying to balance a marble on two moving dinner plates. Everything about the physics suggested the same conclusion. These planets shouldn't survive. The telescopes kept finding them anyway. Then another clue appeared. Many of these planets orbit surprisingly far away from their twin suns, almost as if they weren't born where they are today. That possibility opened an entirely new mystery. Imagine a newborn planet forming in the calmer outer regions of the system, far from the violent gravitational chaos near the stars. Over millions of years, interactions with gas and dust slowly pull the planet inward. It migrates closer until it reaches a narrow region where gravity finally settles into a delicate balance, a cosmic safe zone. It sounded like the perfect explanation, except there was one problem. The safe zone itself shouldn't remain stable for billions of years. Even tiny disturbances could eventually push the planet into disaster. So why hasn't that happened? Astronomers started examining these systems with greater precision. The measurements revealed something unexpected. Some planets weren't following perfectly smooth paths. Their orbits wobbled ever so slightly, not enough to escape, but enough to suggest something unseen was influencing them. Was another hidden planet nearby? An invisible cloud of debris? Or was gravity itself behaving in ways scientists hadn't fully understood? Every answer seemed to create an even bigger question. Then researchers noticed something even more astonishing. The changing positions of the two suns created seasons unlike anything in our solar system. Sunrises could occur twice. Shadows could split in different directions. Years and seasons became wildly unpredictable. Imagine standing on the surface and watching one sunset, only for another sun to remain glowing above the horizon. A world with two mornings, two evenings, and a sky that never behaves the same way twice. It sounded almost impossible, yet somewhere in the Milky Way, those skies are real. And the deeper scientists looked into these extraordinary systems, the more one unsettling possibility emerged. Maybe the real mystery isn't how these planets survived. Maybe it's that our entire understanding of how planets are born has been incomplete all along. And one newly discovered two-sun system may be forcing astronomers to rewrite the rules from the ground up. The breakthrough came from a surprising realization. For years, astronomers assumed planet formation followed one universal recipe. Dust becomes pebbles, pebbles become rocks, rocks collide to form worlds. It was a model built from our own solar system, where a single sun quietly dominates everything. But two-star systems don't play by those rules. Researchers began creating more advanced simulations, adding details that earlier models had ignored. Instead of looking only at gravity, they included the swirling disk of gas surrounding young stars. Suddenly, something remarkable happened. The gas wasn't just creating chaos. In certain regions, it acted like a cushion. Instead of smashing together at destructive speeds, small planet-building blocks slowed down enough to survive. Over millions of years, they could grow larger, migrate inward, and settle into stable orbits around Booth stars. It wasn't easy, it wasn't common, but it was possible. That discovery transformed an impossible mystery into an extremely rare cosmic event. Still, another puzzle remained. Most of the circumbinary planets discovered so far are giant gas worlds similar to Saturn or Jupiter. Scientists expected to find smaller rocky planets too, but those have proven much harder to detect. Does that mean they don't exist? Or are our telescopes simply not sensitive enough to find them? That question has enormous consequences. If planets with two suns can survive around two suns, then some of them could exist inside the habitable zone, the region where temperatures allow liquid water to remain on the surface. In other words, a planet with two sunrises every day could also have oceans, clouds, weather, perhaps even life. It's an idea that once belonged only in science fiction. Now it's a legitimate scientific possibility. Modern observatories continue searching for these worlds. Every new detection helps scientists test theories that once seemed certain. Some discoveries confirm old predictions, others completely destroy them. That's how science moves forward, not by proving we're always right, but by revealing where we've been wrong. The story of planets with two suns is a perfect example. The universe didn't care about our expectations. It simply showed us something stranger and perhaps more beautiful. When you look into the night sky, every bright star appears calm and solitary, but many of them are actually part of binary systems, quietly orbiting another star that may be too faint to notice with the naked eye. That means planets like Kepler 16b may not be rare exceptions after all. There could be billions of planets circling two suns across the Milky Way, some frozen, some scorched, some forever hidden in darkness, and maybe a few with skies unlike anything humanity has ever imagined. One day, future telescopes may capture the atmosphere of a rocky circumbinary planet. They might detect oxygen, water vapor, or chemical signatures that hint at biology. If that happens, the first evidence of life beyond Earth may come from a planet that scientists once insisted could never exist. That's the greatest lesson hidden inside this discovery. Nature is under no obligation to follow our assumptions. Every time we believe we've figured out the universe, it quietly reveals another exception, another impossible world, another mystery waiting in the darkness. Somewhere hundreds or even thousands of light years away, a distant horizon may already be glowing beneath two rising suns, a place where shadows stretch in opposite directions, where seasons follow rhythms we barely understand, where the impossible became reality long before humanity ever looked up. And perhaps somewhere on that extraordinary world, another civilization is staring into its own sky, wondering whether planets with only one sun could actually exist.